I'm Anil Kumar sharing with you a test question on differential equations. Find the curve y equals to f of x that passes through 2, 3 and satisfies dy dx equals to square root x minus 4 minus x, right? Let me write small x. So that's the question for you. You can always pause the video, answer the question, and then look into my suggestions. So we need to solve the differential equation dy dx equals to square root of x minus square root of 4 minus x. We are given the initial conditions that it passed through points 2 and 3. That means when x is equals to 2, y is equals to 3, right? That will help us to find the value of the constant. Otherwise, we always get a general solution for any differential equation. Now, since that is the antiderivative of this, so y equals to f of x, we can write f of x is equals to antiderivative of square root is this power is half. If you add 1 to it, it becomes 3 over 2, right? So let me write down this step here. So I'm doing half, this is 1, plus 1 divided by half plus 1. Let me write like this, half plus 1, which is 3 over 2, but I'll write it in the next step, okay? Now this is minus. Now here, this derivative will be negative 1, so you have to take care of that one. So again we get 4 minus x to the power of half plus 1 divided by half plus 1, and since the inside derivative is negative, we should make this positive. So that is the thinking which goes on when we do such questions, correct? So first step is normally to write your radical with rational exponents and then add 1 and then do the needful, right? Okay. So we get our equation here as, let me rewrite this, as x to the power of 3 by 2, right? Now when it is 3 by 2 in the denominator, let me go one more step, okay? At times I've felt that in the books we skip these steps, so it becomes difficult for some to understand what's going on, right? So anyway, this is easy. Now you'll see this fraction in the denominator. It could be written as 2 over 3 for both the cases. So let me write 2 over 3. And then what we have here is x to the power of 3 over 2. We could take this common, right? So, okay, we'll take it common in the next step. Plus 2 over 3, 4 minus x to the power of 3 over 2. So let me take this 2 over 3 common. So if I take 2 over 3 common, we get x to the power of 3 over 2 plus 4 minus x to the power of 3 over 2, right? And I should have written plus c when we did antiderivative, which I'm going to add now. So always you have to add a constant, otherwise it is not the general solution, right? So let's put c here, constant c. Given initial conditions, which is this, helps us to find the value of the constant c. That's the whole idea. So once you have found a general solution for your differential equation, then using the initial conditions, we could find the value of c. So now let us substitute what is given to us. So this is general solution. So now we say for f of 2, what is the value? F of 2 is 3, right? So let me write this as, we know f of 2 is actually given to us as 3, right? So we have 3 equals 2. So I'm substituting 2 here. So we get 2 over 3 within brackets. 2 to the power of 3 over 2 minus 4 minus 2 to the power of 3 over 2 plus c, right? Now what is 2 to the power of 3 over 2? Because I'm running out of space, I'll do this on the side. Okay, so when we say 2 to the power of 3 over 2, so it really means if I write 2 to the power of 3 over 2, then it really means 2 cubed, which is 8, and the square root of 8. So it is basically square root of 8, correct? And square root of 8 could be written as 2 square root 2. 8 is 4 times 2, so it could be written as 2 square root 2, right? Let me add one more step here that may help. 4 times 2 is 8, and then from here we could write 2 square root 2. So that is 2 square root 2 for us. Okay, I'm sorry, this was plus in between. This is plus, I made it minus. Okay, so that is what you have here. So basically, from here we get the equation that this implies 3 is equal to all this, right? Within the bracket, this is also 2 to the power of 3 over 2, right? Do you see that? So we could now write this equation as 3 equals to 2 over 3, and within brackets 2 to the power of 3 over 2 is 2 square root 2, right? So we have here 2 square root 2 plus, since 4 minus 2 is also 2 to the power of 3 over 2, let me write 2 square root 2 here also, right? Plus c. So that becomes your equation. And from here we can solve what c is. So we can say what c is. C is equals to 3 minus 2 over 3, and within brackets we have 2 square root 2 plus 2 square root 2. That means 4 square root 2, right? Times 4 square root 2. Correct? So that is 4 times 2 is 8. So I could write this as equals to 3 minus 8, 4 times 2, square root 2 over 3, right? So that becomes the value of c. Now once we have the value of c, we can write the specific solution for the given situation, correct? So from here, we'll substitute the value of c in our equation, okay? So which is, we could do anywhere, anyway, so which is this one. Okay, we'll do that, substitution. So once we substitute, we get our answer. Let me change the ink now. So the final answer here is that f of x equals to 2 over 3 you could write this in radical form also if you want, which is square root of x cubed plus square root of 4 minus x cubed plus the value of c, which is 3 minus 8 square root 2 over 3, right? So that becomes the solution for the given differential equation, right? Let me highlight this one. Okay, have a good look at it. So that is how we could actually solve it. I wrote it in this form since the question was in the same form, right? So it's always good to write in the same form as the question is given to you. I'm Anil Kumar. You can always share and subscribe to my videos. Feel free to share questions. Thank you and all the best.